Hi everyone, so this is the second video in the AVL tree series, and in this video we are going to be talking about the idea of node balance. So an AVL tree is a height balanced binary search tree. So one of the things that we want to be able to do is to be able to identify whether or not a tree is height balanced. To help us with this, we're going to introduce a value called a nodes balance. Now, a nodes balance is a value at every single node. So every node has its own balance value. And that balance value is calculated by the height of the right subtree of a node and subtract from it the height of its left subtree. Okay, so that's the formula that I have written there. Now, let's do an example given this tree. So we're going to start off with this binary search tree. Don't worry about what the numbers are going to be. So the numbers I'm writing in here are not the numbers we're storing. What I'm writing in is only the balance values, okay? So in order for me to calculate the nodes balance, I have to first determine the height of the right subtree, the height of the left subtree, and then I have to subtract the two. So the height of the right so this is the node that we are trying to calculate the balance on, the root node. And what I want to do is I want to ask the question, how tall is this tree? How tall is this tree over here? Now, by this subtree, what I'm talking about is this part right here only. Now, this particular tree, okay, the right subtree, is effectively everything to the right of the node. Okay, so the right subtree of a node. And we calculate a height of a tree by taking a look at how many nodes there are from the root to the leaf inclusive. So in this case, the farthest away leaf node in this tree is this one here. And this is the root of that tree. So if I take a look, there's 1, 2, and then 3. There's a total of 3 nodes from root all the way to its farthest leaf. So the height of this tree is 3. 3 nodes from root to leaf. So this tree is 3 nodes tall. Now, if I take a look at the height of the left subtree, that's this tree right here, starting at this node all the way down to here. Now, the farthest away node is either this one or this one. Doesn't matter which one it is, pick one, not both, and calculate and count how many nodes there are from that node to the root of that subtree. So this is 1, 2, 3, 4. So this tree has a height of 4. Okay? Now, oops, don't want to do that. So now we have the height of the right subtree and the height of the left subtree. So all we have to do is put those values into our formula. The height of the right is 3. The height of the left is 4. And if we do the math, what we end up with is minus 1. So what this means is that the balance at the root is minus 1. Okay? The height of the right, 3, minus the height of the left, 4, gives you minus 1, which is the balance at the root. Now, let's do another example. Okay, so let me take a different node here. Let's take a look at this node right here, the leaf node. Now, this is a leaf node, which means that there are no children. So the right subtree and the left subtree, they don't really exist. So what is the height of a tree that doesn't exist? Well, it is exactly 0 nodes tall. Doesn't exist, right? So what that means is that the formula that I'm calculating now is that this tree has a height of 0. This tree has a height also of 0. So the height of the two of the trees that doesn't exist is 0. And thus 0 minus 0 equals 0. And so the balance at the leaf node here is 0. Now, in fact, you can say that for any given leaf node, any node that is a leaf, the balance will be 0. So right away, we can actually say that this balance is 0, this is 0, this is 0, this is 0, this is 0. So it leaves only a few more nodes to look at. Now let's take a look at this tree right here. What is the balance? Sorry, not this tree. Let's take a look at the node right here. Oops, the node that I just erased. This node right here. What is the balance of that node? Pause this video and do the calculation, and then give yourself a few seconds to do it, okay? Okay, so hopefully you've done this. Now, if you take a look at this, the balance here, that tree, the right subtree, has a height of 2 nodes. The left subtree has a height of 1 node. So if we use those numbers and apply our formula, what we get is 2 minus 1, okay? We don't look at the balance values in the tree when we're calculating. We actually just take a look at the height and then make the calculation. So over here, this is positive 1, okay? Plus 1. So this node has a balance of positive 1. All right, now let's take a look at one more node, and then we'll do the other. I'll leave the others as an exercise. So what is the balance right here, this node? Okay, so the height of the right subtree here is 1. The height of the left subtree, which doesn't exist, is 0. So 1 minus 0 gives you a total of plus 1. So the balance of that node is also plus 1. Okay. All right. So see if you can calculate the balances of the remaining 3 nodes. A, B, C. Give it a go. All right. Let's very quickly take up what the values are. So let's start with A. Okay. For A, the balance is the height of the right, which is 1, and minus the height of the left, which is 3. So this tree is 3 nodes tall. So our formula is applied, and we get 1 minus 3. So what that is minus 2. So A has a balance of minus 2. Let's take a look at B. B over here. What is the balance of B? Now, again, what is the height of the right subtree? This is 2. What is the height of the left subtree? This is 1. So 2 minus 1 will give you a total of positive 1. So the balance at B is positive 1. Okay? Oops. Last one. So last node to look at is this node right here. What is the balance here? So the height of the right subtree is 1. The height of the left subtree is also 1. So 1 minus 1 has a total of 0. So the balance at C is 0. So you will notice that I'm not adding or subtracting balances. You can't do it that way. Okay? What you have to do is you have to calculate the balance based on only the height. Okay? You can't do it based on balances, not without a bunch of conditionals. So don't do that. This is how you calculate the node's balance. And this is really important because this is how there's actually a whole bunch of things that we can actually tell by looking at the balance of a node. Okay. So what do we actually know? What can we tell about a tree based on a node's balance? Well, the first thing is the following. Take a look at all the nodes that are positive here. These ones are positive, right? Now, if you take a look at those nodes, ask yourself which side is taller in each case. So if we look at this one, the right-hand side is taller. And if you take a look at each of those nodes, the right-hand side of those nodes, the right subtree, is the taller tree. So the fact that you have a positive balance, okay, positive balance means right right subtree is taller. Okay, how much taller? Well, that's where the number comes in. So +1 means that the right subtree is taller by one node compared to the left subtree. If we take a look at the node over here, this -2, okay? If it is a negative value as opposed to a positive one, a negative balance, okay? So if the balance is a negative value, what it means is that the left subtree is taller. Okay, so the left-hand side is taller if the balance is negative. Okay, so positive, right side is taller. Negative, left side is taller. So if all I give you was the nodes balance, you can actually tell right away which side is taller and by how much. Okay, now in order for a tree to be height balanced, a tree, so we're talking about the entire tree here, not the subtree. Okay, the entire tree is height balanced. Okay, so remember, this is what we're aiming for, right? And you can say that an entire tree is height balanced if every node has a balance of +1, -1, or 0. So either +1, -1, or 0. If even one node is not one of those three values, the tree is not height balanced. So if we take a look at this tree, what we know is that this tree is not height balanced because there is one node, this one right here, okay? And it only takes one node to spoil it all, okay? It doesn't take like a whole bunch of nodes for this to be true. If even one node is not +1, -1, or 0 in terms of its node balance, what you will have is you will have a tree that isn't height balanced. So this tree is not height balanced. And all it takes is one node where the balance is off by more than one. Okay, so this tree is not height balanced because we have a node that is -2. Okay, it's as simple as that. So any value that isn't 0, +1, or -1 means that the whole tree is not balanced, not the subtree, the whole tree. Okay, so the whole tree not balanced because one node is not 0, +1, or -1. Okay, all right, so that's it for this video. In the next video, we will actually take a look at how we do insertions. Okay, see you then. Bye-bye.